Okay, shall we start now? And there is a doubt in the question in sheet 1 of acceleration and question number 6th. So 6th question in sheet number 1 of acceleration. Okay, someone read the question for me. If acceleration A is equals to 60 plus 1 I cap plus 3 j cap at t is equals to what? 0 seconds. The object is at 2, 3. Object is at 2, 3. At t is equals to 0, object is at 2, 3. Then next. And its initial velocity, that is u is equals to I plus 2 j cap. Find r at t is equals to 1 seconds. Okay. Check the values. 60 plus 1 j I cap plus 3 j cap and 2, 3. And u is equals to I plus 2 j cap. Yes? Okay. Now, acceleration is given and they ask you the final position. Let this call as final position. Initial position is given. Na? What is your initial position? 2, 3. How to write initial position? So, R initial can be written as, this can be 2 I cap plus 3 j cap. Okay. Initial velocity is given. You need to calculate final velocity. So, final velocity minus initial velocity will provide you the things. Na? So, now, acceleration. Acceleration can be written as dv upon dt. Yes or no? And acceleration can also be written as, so this dv is equals to a dt. And dv is nothing but v final minus of v initial, which is equals to integral a dt. Can I write like this? Yes? Okay, now. We don't have v final, but we have v initial. This is your initial velocity, na? Okay. And do you have the value of a? Yes, we have the value of a. Substitute and get the answer. Now, v minus of initial velocity I cap plus 2 j cap is equals to integral of 60 plus 1 I cap plus 3 j. Now, v minus of I cap minus of 2 j cap, which is equals to, this can be written as 60 square upon 2 plus of t I cap plus of this 3t j cap. Now this once, this thrice. So v is equals to 3t square plus of t. Nothing means 1, na? Plus of 1 I cap plus of 3t. Over there goes 2 j cap. Can I say this is the value of your velocity? Okay, now, do you have final velocity? Do you have initial velocity? Do you have the initial position? Yes. So, can I also say that v is nothing but dr upon dt? Can I? Okay. So, dr can be written as v dt. Yes or no? And this dr can be written as r final minus of r initial integral of v dt. Can I? Okay. Now, what is your v? So, r final, let r final is r minus of r initial value 2 I cap plus of 3 j cap and v integral of 3t square plus of t plus of 1 I cap, then next plus of 3t plus of 2 j cap. Okay. Now the same thing can be written as r minus of 2 I cap minus of 3 j cap, which is equals to integration of that, this becomes 3t cube upon 3 plus of t square upon 2 plus of t I cap plus of 3t square upon 2 plus of 2t j cap. Okay. Now, taking 2 I cap and minus 3 j cap on that side. So, R is equals to t cube plus t square by 2 plus of t, and this becomes over there 2 I cap plus of 3t square by 2 plus of 2t, taking this 3 j cap on that side plus of 3 j cap. Anything cancelled? Nothing. So substituting t is equals to 1. So R becomes 1 plus of 1 by 2 plus of 1 plus of 2 I cap plus of 3 by 2 plus of 2 plus of 3 j cap. Okay. And solving this, 3, 4, 4 plus half, 9 by 2. So R is equals to 9 by 2 I cap plus of 3 to 5, 5 to 10, 10, 3, 13. So 13 by 2 j cap. How many of you got this answer? Very good. So finally we can also write that in point, or that is 4.5 I cap plus of 6.5 j cap. Okay, note down. Okay, shall I now write the heading? Equation of motion. Okay, now very easy topic again, and all you need to understand why we are learning this. Generally, you learned in your 9th standard, 10th standard, na? S is equals to ut plus half at square, v is equals to u plus at, and v square minus u square is equals to 2as. Yes or no? So we are going to learn those things only, but we will learn in a different way now. Okay, now, so first equation, S is equals to ut plus of half at square, and second is v is equals to u plus of at, and the third is v square minus u square, or v square is equals to u square plus 2as. And there is one more equation for snth time. We will discuss that one. Now, first thing, these three equations are only applicable if acceleration remains constant. Okay. Yesterday we got some equations like 2 I cap plus 3 j cap acceleration value, like this. A is equals to 2 I cap plus of 3 j cap, and somewhere we also got A is equals to 2 t I cap plus of 3 j cap, like this also, na? This means acceleration is changing its value with respect to time. Okay, acceleration is dependent on what? Time. Over here, acceleration remains constant. For example, a body is traveling in this direction from A to B. If I say there are multiple points in between, at this point let t is equals to 1 second, acceleration is 2 meters per second. At t is equals to 2 seconds, acceleration must and should be remaining 2 only. At t is equals to 3 seconds, acceleration should remain 2 only. Okay. So it should not change with respect to what? Time. If it is changing, for example, in the next, at this point t1 is equals to 1 second, acceleration is 2. At t2 is equals to 2, acceleration may be 3. At t3 is equals to, acceleration is 2. So variable acceleration. If acceleration is time dependent and acceleration is constant. If acceleration is constant, then and then only we can use all these three equations. Okay. Now, in this, S is your displacement. Okay, it is not distance, it is displacement. Okay, U is your initial velocity and V is your final velocity. A is acceleration and T is time. But over here again I am telling you it is only applicable if A should be constant. Okay, now let us derive all three equations from where they are coming in reality. Okay, now listen to me. As we all know that acceleration is nothing but dv upon dt. Acceleration is nothing but dv upon dt. Okay, now can I also write this as dv is equals to a dt? dv is equals to what? A dt. Now what I am saying is acceleration should remain constant. That means can I integrate these two only? dt and dv. At t is equals to 0, initial velocity is u. At time t is equals to t, final velocity is what? V. So can I integrate and tell this? That means this becomes v minus u and this is nothing but at. Or can I also say that v is equals to u plus of at? Stop writing and just listen to me first. So this is your first. Similarly, can I also write a is nothing but dv upon dx? v dv upon dx. Whenever velocity is a function of x, velocity is a function of t. So can I also change this as a dx is equals to v dv? Can I? Okay, now again a constant. Over here v. When displacement is 0, initial velocity is u. When displacement remains moved to the x value, final velocity becomes v. Why u and v? Arey beta, dv is written na. So you should be putting v value. That means velocity value. Over here we have written dt na. That means we have substituted t. Integrating with time when dt is given. Integrating with velocity when dv is taken. Okay. Now a is constant as it is a and this becomes x. Similarly, integration of v is nothing but having a power 1. So v square by 2. And the upper limit is v, lower limit is what? U. Ax is equals to, can I write v square minus u square by 2? Can I? Okay, upper limit minus lower limit by 2. Or this can also be written as v square minus u square, which is equals to now 2as. Instead of x, I am writing s now. Okay, then third one. Again acceleration, how we are deriving? We have taken acceleration constant. Acceleration is constant, acceleration is constant. Again, the third one, how to find third one? So v is equals to dx upon dt. X is a function of time t, v is a function of x, v is a function of t. Got my point? Yesterday we are doing that only, na? Now, this can be written as dx is equals to v dt. Okay. Can I also write this as dx is equals to, what is the value of v? Can I substitute u plus of at? Okay, so u plus of at dt. Integrating this. Now integrating for the time, na? So 0 to t and this is 0 to x. So this becomes x is equals to, can I separate these two? U dt integration of 0 to t plus of a integration of t dt 0 to t. Again, a is what? Constant. Now, x is equals to, this becomes u dt. So u t plus of, and over here, this can be written as a t to the power of 1. So this becomes t square upon 2, or x. Instead of x, I am writing now s. S is equals to ut plus half at square. Write down now. Okay, shall I? Then fourth one, distance traveled for nth second or nth time. So what is the meaning of nth time? First thing. Okay, now listen to me first. For example, body started from 0 second. It reached to first second, then over here 2 seconds, over here 3 seconds, and similarly at this point it reached to 4 second. Okay. Now how much body traveled in 4 seconds? Listen carefully. Whenever I am asking how much body traveled in 4 seconds, that means can I say that body traveled from initial point to final point? Body traveled how much? In 4 seconds from initial to final. But can I say that body traveled in 1 second? That means starting from 0 to this. It is traveling in 1 second now. Starting from 0 to 1. Okay. If I ask you how much body traveled in nth second? Nth. The word we are using nth. For example, how much body traveled in third second? So can I say that body just traveled between 2 second to 3 second only? Are yes or no? Or can I say that body traveled in 4th second? This is the distance traveled in 4th second. Aya. So body is not traveling in 4th second full distance. Body is only traveling this distance. That means it is completing after 3 seconds and just completing after 4 seconds. Started from 3, ended at 4. I got my point? So can I say that if we are talking about nth second, nth is nothing but can I say n minus of n minus of 1? Meaning 5th, if we are talking about 5th, minus of 5 minus of 1, that is 5 to 4 we are talking now. I got my point. So this can be written as 5th. Got my point? So can I say that n minus of n minus of 1? N minus of 1 is nothing but your nth. Okay? Now, let us try to derive that. So, considering t is equals to n and t is equals to n minus of 1. Okay, how much distance traveled? So, s is equals to ut plus of half of at square is our formula, na? Are yes or no? S of nth. So, I am substituting t is equals to n in this one. So, un plus of half of an square. Can I? Similarly, for t is equals to n minus of 1, Sn minus of 1 is equals to un minus of 1 plus of half of a n minus of 1 whole square. Can I? Or Sn minus of 1 can be written as un minus of u plus of half of a, expand this, n square plus of 1 minus of 2n, or Sn minus of 1 can be written as un minus of u plus of half a n square plus of a by 2 minus of a n. Okay, 2 get cancelled now. Now, for Snth, it is nothing but n minus of n minus 1. Okay, subtracting these two. So this is your first and this is your second. Subtracting these two. For Snth, Sn is what? Un plus of half an square minus of un minus of u plus of half an square plus of half an square plus of a by 2 minus of an. Can I write like this? Expand this. So Snth is equals to un plus of half an square minus of un plus of u minus of half an square minus of a by 2 plus of an. Can I? And cancelling un, an square. Anything else? No. So Snth can be written as u plus of an minus of a by 2. Can I write like this? Or this also be written as, in many books it is written as u plus of a by 2 taken as common. Left out is what? 2n minus of 1. Write down first. Okay. Let us start with examples. Example number 1. Consider an object is placed. Let the object name is A, and this object is moving in this direction. Given that u is equals to 10 meter per second, and the acceleration is also along the direction of motion. So A is given 2 meter per square second. Question is, find final velocity and distance. ऐसा लिखता हूँ. Find final velocity and distance traveled in 4 seconds. Okay, try this. Okay, shall I now? So for velocity is equals to u plus of at. For final velocity, we are using this equation, and we don't know final velocity v. We know the initial velocity, that is 10, plus of acceleration is how much? 2. Time period they substituted 4 seconds. Okay, so this can be written as v is equals to 4 to 8 plus 10, that is 18 meter per second. This is your final velocity. Similarly, for distance traveled, s is equals to ut plus of half at square. S is equals to ut plus half at square. Okay, now first tell me what he asked you. Distance travel, but this formula is for displacement. Now listen to me. Initial velocity is 10 meter per second. Acceleration is 2 meter per square second. That means, can I say that in every second velocity is increasing by 2 meter per second? Can I say that? In first second velocity is 12, then in second that velocity becomes 14, then 16, then 18, then 20. Is it any possibility of changing the direction? Is there any possibility that body will be changing or retracing back to its original direction? अरे यार, ये ऐसा जा रहा है ना? This one is going in this direction. At this point, what is the velocity? Let it maybe 10, then 12, then 14, then 16, then 18, then 20, so on it will be increasing. Na? Is there any possibility of this object having velocity 0? No, na? That's what I asked you. That means body will not be coming back again. Got my point? Okay, now, so can I say that in this situation, distance and displacement both will be equal? Okay, now, S, we don't know. U, 10, time period 4, plus of half of acceleration to t square, that means 16, 2 get cancelled. So S is equals to 40, 40 plus of 16, that is 56 meters. Okay, right on. Okay, shall I? Example number 2, 10 rupees. Okay? Yes, 10 rupees. Are chinna question na babu, only 10 rupees. Now keep quiet. Consider object A is placed again. Velocity is given, u is equals to 10 meter per second in this direction. And acceleration is given opposite to the direction of motion, that is what? 2 meter per square second. Find velocity and distance traveled in t is equals to 20 seconds. Try this. You have only 1 minute. Okay. Shall I now? Now, let me see how many of you have done correct. So, final velocity v is equals to u plus at. So, v is equals to what is initial velocity? That is 10 minus of acceleration 2 into time, that is 20. Why I am writing minus? Opposite direction. Yes. So, v is equals to, this is 10 and this is minus of 40, or v is equals to, can I say, minus of 30 meter per second. Okay. U is 10, A is minus 2, and time period is 20 seconds given. So substituted and we got minus 30. Okay. First I will tell you. Whenever you see a time value, velocity value negative, initially it is positive. Finally, yes, definitely it is returning back. That means distance and displacement will be different. Okay. Now, so if you calculate S is equals to ut plus of half at square. If you substitute this, first listen to me. I know everyone has done wrong. So stop writing and just listen to me. So S is equals to, what is u value? 10. Time value 20. Minus of 1 upon 2 into acceleration 2 into time is again 20, that is 400. 2 get cancelled. So S is equals to, can I say this is 200 minus of 400, and S is equals to minus 200 meter. You got this displacement. But the question is asked on distance traveled. That means this value provides you displacement. For distance, this answer is wrong. Okay, now listen to me. Then what is the correct answer? So by checking this velocity, or second thing, yesterday we discussed about acceleration. Acceleration can be positive, acceleration can be negative. Okay, now whenever acceleration is opposite to the direction of motion, body is going in this direction, acceleration is in that direction. That means, can I say that after 1 second velocity will be 8 meter per second, then after 1 more second velocity will be 6, then it becomes 4, then it becomes 2, then after finally it stops, velocity becomes 0. That means, can I say that in 5 seconds, just by seeing that acceleration and velocity, I can say body will be having 0 velocity after 5 seconds. So how to find that? U plus of at. So v is equals to u plus of at. Velocity should be equal to what? 0. Checking velocity is getting 0 or not, first thing. So u, initial velocity 10, acceleration is in the opposite direction, that's the reason minus. So 2 into time, we don't know, 2t, which is equals to what? 0. So t is equals to 5 seconds. T is equals to what? 5 seconds. At t is equals to 5 seconds, body is retracing back to its original path. Okay, now, then what is the correct answer? So first thing, either calculate displacement for 5 seconds first, then for 15 seconds. Okay, I will tell you how. Or either displacement minus of distance, that will provide you the answer. Now listen to me. S is equals to ut plus of half at square. Again we are using this. But for how much time? We should be using this only for t is equals to 5 seconds. Because body is going in this direction. Body is going in this direction. For t is equals to how much? 5 seconds. For t is equals to 5 seconds, body is going in that direction. After that, at 5 seconds, t is equals to 5 seconds, velocity is getting what? 0. Okay, now, s is equals to, what is u? 10. Time period, I am saying 5. Plus or minus? Minus. Why? Because acceleration is still in that direction. So, minus of half into acceleration is 2 into, can I write 25? So, s is equals to 50 minus of 25, that is 25 meter. Okay, so if this is your origin, body traveled in this direction, how much? 25 meters in this direction. Okay, now, then we got displacement is equals to minus 200. That means from here, can I say that at this point, there will be a displacement minus 200 meter now? Yes or no? Okay. So in this direction 20, this is your origin. From here to here how much? 200. From here to here how much? 25. Body started in this direction, moving 25. Then from here to here 25. Then from here to here 200. That means total distance traveled by the body is 250 meters. Okay. What I said is, you got s is equals to 200. And you got s is equals to 25. That means 25 in this direction, then 25 in this direction from origin. Then from here to here, 200. So this is 25, this is 25. Total is what? 250. Or the second option, what you have to do is, shall I rub this side? No. Okay, I will try to explain here only. Now, the second option, what to do is, first thing you have taken, total time is given 20 seconds. You have utilized how much? 5 seconds. Left out is 15 seconds. So, s is equals to ut plus of half at square. Now, body is moving in which direction? Body is moving now in this direction. In previously 5 seconds, body moved in this direction. Now, body is moving 15 seconds in this direction. Acceleration is also in this direction. So acceleration for this one positive, and in this direction acceleration is negative. Okay, now complete this, I will do the answer. Again using this equation. Now when the body is retracing, what is the velocity at this point? 0 now. So for in this direction, initial velocity is 0, final velocity we don't know, but we don't require final velocity at all. So initial velocity in returning direction is 0. So s is equals to half of 2 into 15 square, that is what? 225. Can I cancel this 2 and 2? So s is equals to 225 meters. Now s is equals to 225 meter in this direction. S is equals to 25 meter in this direction. So total distance is s is equals to 225 plus of 25, that is s is equals to 250 meters. जैसे लिखना है लिख लो.